if I were going to try to like classify chapter 4 and compare it to chapter 3, I would essentially say this. Chapter 3 was helping you learn how to graph a line on a graph. Chapter 4 is going to be about graphing more than one line on a graph. Maybe 2. Could be 3, 4, 5, 6. We're going to focus on just 2 though. Okay? So let's look at the little sentence here at the start. It says, when 2 or more equations with the same variable are considered at the same time on the same graph maybe, they form a, Alec? System. Yes, that's what we're talking about in this chapter. System of equations. That's the terminology. Bless you. So system of equations simply means that you've got more than one line happening at the same time on the same graph perhaps. And what does it all mean? Like what do we do with that and how could we use it and apply it to some situation that could be helpful? So the first thing we're going to do is really the thing we always start off with is learning how to check a solution. And so we've got a system right here. The system is 2x plus y equals 11. So this would be like line number 1. There's the first line. Here's line number 2. Y equals x minus 7. So you got 2 lines right there. And we are being told that 5, negative 1 might be a solution to this system. And so our job is to check. How do we usually check things? Plug it in. So if you would, plug in and let's determine whether that point, 5 comma negative 1, really is a solution to the system. So take a minute and do that. So as is typical, this is kind of a yes or no question, right? So Avery, what do you say? Yes it is or no it's not?
No.
No? Okay, so Avery says no. What would be your work to back that up? What did you write?
So I plugged the 5 in for x and negative 1 for y.
Okay, so 2 times 5 plus negative 1 equals 11.
Yeah, and then it would be 10% negative 1, but that would be 9, not 11.
Of course, yeah, like you said, 9 does not equal 11. Yeah. And so, yeah, that alone right there tells us that it's not a solution. In order for this point to be a solution, it would need to work in both lines. If it works in one, you still got to check the other. So this one, we picked the one, at least for sure, this one shows it's not a solution. And so we could stop right there and like Avery said, no. Did anybody try the other line?
Yeah.
It doesn't work there either, does it? Yeah, so this is just not even on either line. So it's possible you could have the point work in one of the 2 lines, but not both. It could work in both, or it could work in neither like this one. So this is feel pretty familiar. We've done stuff like this at the start of every chapter. Check to see if this is a solution. Hopefully you're getting pretty good at that. We good?
Yes.
Okay, so let's go ahead and move on to example number 2, where we're actually going to be finding a solution to one of these. Let me get there. By graphing. I hope you all brought your calculators with you today. We're going to use those calculators at the end. So take a look at number 2. It says solve the system by graphing, and it gives us this nice system, x plus y. No, don't use your calculators yet. Not yet. We'll use them in a little bit. X plus y equals negative 4. X minus 2y equals 2. What do you guys see as a good way of graphing this? Like what method? What do you think?
Intercepts.
I think intercepts would be easiest. If you don't want to do intercepts, it didn't tell you how to do it. Couldn't you also do slope intercept? But I think intercepts would be easiest. So take a minute, you decide what's going to work best for you, and do that. Graph both of these lines on the graph, and then we'll talk about what the graph means, right? What we're actually looking for. So this is, like this right here is one line. I'm going to call it line number 1. So for line number 1, I'm going to have an x-intercept and a y-intercept, right? So my x-intercept, to find the x-intercept, you plug a 0 in for y. So it'd be x plus 0 equals negative 4. Well, that's pretty easy, right? That's just negative 4. Okay, so I'm going to go to my graph. My x-intercept is negative 4. So 1, 2, 3, there it is. Right, and then my y-intercept is going to be the same thing, isn't it? You plug a 0 in for x. So 0 plus y equals negative 4. So my y-intercept is also negative 4. So 1, 2, 3, 4, right there. And then I'm going to do my best to draw a straight line between those. So this is just line number 1. We have not dealt with line number 2 yet. So far, so good? That makes sense? So 2 separate lines, right? That's kind of the missed connection there. Okay. So then line number 2 is, of course, the other one here. So line number 2, we're going to have an x-intercept and a y-intercept for that one. So the x-intercept, you plug a 0 in for y, so you get x minus 2 times 0 equals 2. Of course, 2 times 0 is just 0, so you get x equals 2, right? Yeah, x-intercept of 2. Okay, so 1, 2, there it is.
Wait, x-intercept, or is that?
Oh, let's go with an x-intercept. Thank you. Look better?
Yeah.
Okay.
Can't mess with my
That's how my brain works sometimes, because I was already thinking y-intercept, and the letter y must have stuck in my brain, and I went to the y-axis. Oops. Okay, so to find the y-intercept, you plug a 0 in for x. So it'd be 0 minus 2y equals 2. We divide both sides by negative 2, and I get a y-intercept of negative 1. So negative 1 is right about there. I connect those 2 points, like so, and I've got my 2 lines. So let's stop for just a second. We'll draw a conclusion here in just a second, but for now, are we okay with the graphing of the lines part, right? 2 separate lines using intercepts. There they are. Do you see how basically this was just 2 problems in chapter 3 combined into one? Graph this line, graph that line, graph it on the same graph. That's kind of it. And so, guys, here is the big reveal. Maybe you already know this, but the solution to a system, at least on a graph, is where the lines cross, where they intersect, where the 2 lines intersect. So I would look at my graph here, and I think that I've done a pretty good job here with my graph using some pretty straight lines. I think it's pretty accurate. I would say that the solution to my system would be negative 2, comma, negative 2. Because right there, that is where the 2 lines actually intersect. Negative 2, comma, negative 2. So on a graph, all we're really looking for is where do the lines intersect? And wherever they intersect, that's the answer. Let's think about what that means, though. Isn't that point right there, isn't that the place where the 2 lines are equal? That's the place where the 2 lines share the same space at the same time. So that's the only point that makes both equations true. It's the only point that makes both equations true, and so that's why that's our solution. Would it be fair to say that a graph is a pretty notoriously unreliable way of getting a perfectly accurate answer? Yeah. So, let's say you're doing a question like this and you just thought, well, it sure looks like negative 2, but do I have any reason to think that it wouldn't be negative 1.999, comma 2.001? Like, honestly, is there any way to tell on a graph that it's not that? No. There's no way. So how could I check negative 2 to see, is this really my answer? It's like what we did in number 1, right? Just plug it back in. And so I think if you do that, you see that it is right. So up here, negative 2 plus negative 2? Negative 4. Negative 4, it works. Right here, it would be negative 2 plus 4, which is positive 2. So it does work out just fine. I'm not going to try to trick you and give you some system where the solution is like 1.9998 or something when it looks like it's 2. We'll look at other methods if we're going to do something like that. But just know, you can always check it by plugging back in. Big takeaway. Let's take this away. The solution to a system is where the lines cross or intersect. Yes. All right, we good? I think you have a couple of chances here for some practice. So let's take a look at numbers. I think numbers 3 and 4, I think, are both doable for you. So let's do both of those together, numbers 3 and 4. With number 3, I think the y equals 1/2 x. What form is that in right now?
Slope-intercept.
Slope-intercept. So I would say with that we can graph immediately. We can say that the slope is what?
1/2.
And the b value?
0.
Yeah. So the slope is 1/2. The y-intercept is 0. So to graph this, I would put my point right there at 0 for my y-intercept, and my slope is 1/2. So that means up 1, right 2. So right about there. Up 1, right 2. So right about there. I'll do my best to draw this in. There's my line. Not the best line, but good enough. So far, so good?
Yes.
Now the other line, what might be the easier method for the other line? Intercepts could be easier. So you can. You definitely can. But I'm going to use intercepts here. So I'm going to say for my x-intercept, plug a 0 in for y. So that'd be x minus 2 times 0 equals 4. So my x-intercept is 4. 1, 2, 3, 4. And my y-intercept would be 0 minus 2y equals 4. So dividing by negative 2, y equals negative 2. You guys are pretty good at graphing these lines, aren't you? I'm hoping that after chapter 3, we're always going to make a few mistakes, but pretty good at this. So there's my y-intercept. So as I connect those, do you see anything interesting happening?
Their slopes are parallel.
Yeah, it looks like the lines might be parallel. So let's remember, when we have a system of equations, the solution to the system is where
They cross.
they cross. So what is true about parallel lines? They never cross.
No solution.
So that means that there's no solution. Does that seem logical? If we're looking for where they cross and they don't cross, there's no solution. Think about it like this. Remember how I said the point where the lines cross is like where the lines are equal? They occupy the same spot. There is no place like that here, is there? There's no place that makes both lines true. And so we would say to this one, no solution. Again, does that seem logical? I want to make sure that you understand the thinking behind it more than just memorization. If you wanted to boil it down to memorization, you would say parallel lines as a system have no solution, ever. Yeah.
So in this case, it would have been like easier to do both of the slope-intercept because you can just see the slopes and you know.
Perhaps, yeah, you could have seen it right there. Yep. And this one said graphing, so you kind of had to graph, but that could have been an easier way. Yeah, I agree. Or faster, at least, right? Okay, awesome. Let's take a look at number 4. With number 4, the top line probably intercepts, right? You guys are getting really fast at this, so maybe, I'll show the steps. So the x-intercept, this is for the top line right here. X-intercept would be x plus 3 times 0 equals 6. So the x-intercept is 6. So 1, 2, 3, 4, 5, 6. Y-intercept, plug a 0 in for x. So 0 plus 3y equals 6. I'm getting a y-intercept of 2. Doing okay? All right, so y-intercept of 2, right about there. And we try to connect those 2 points. I missed. Kind of missed again. There we go. So there it is. Now the other line is, of course, in slope-intercept form. And this is where you start to notice some interesting stuff. For example, did you notice what the y-intercept was on that line? 2. So I immediately am kind of interested in this because when I go to graph a y-intercept of 2, aren't I right there, right on top of that other line? Okay. Fair enough. Maybe that's where the lines cross, right? Maybe. So the slope is negative 1/3. So that means to go down 1, right 3. So if I go down 1, right 3, look at where I'm at. Aren't I still on that line? And then if I go down 1, right 3, I'm still on that same line. So as I try to connect those points, isn't my blue line essentially right on top of my green line? Yeah? I'll get your question in a second. So essentially what we have here is the same line. If I had taken this top green line and put it in slope-intercept form, wouldn't I have seen that? Maybe some of you did that. It's like already it's the same line. So remember, the solution to a system is where the lines cross. So, yeah, it's not, okay, I can kind of live with that, but the question is more about, where do they cross? How many solutions are there? You could say all real numbers. You could say infinitely many solutions. I think I would take either one because isn't infinitely many solutions implying that all the real numbers would work? So I would be okay with either one. So if you said all reals, all real numbers, or if you said infinitely many solutions, I'd be okay with that as well. Please don't put infinity, because infinity versus infinitely many solutions is a little different description.
Can we put infinite solutions?
Sure.
Infinite times
Infinite
sign.
sign? Oh, no, because this right here just means infinity. And the answer is not infinity. The answer is there are infinitely many solutions. So you have to write all real numbers or infinitely many solutions, really. That would be the best way to describe this. All right, what do you think? Any questions? Okay, got maybe one or two more things to do here and we'll close it up. In your notes, we've outlined all three cases so far. The three cases, if you have two lines, you could have the lines intersecting in one point. Like you can see the picture, that was like our first one. You could have the two lines being parallel. That means there is no solution. You could have the lines being the same. That means that there are infinitely many solutions. Any point on the line will make both equations true. So those are the three cases. We've just covered all three cases, but that's kind of a little table that kind of shows you all three cases in a quick little way to compare. Does that make sense? Do you see how that agrees with what we've just done? Okay, fair enough. All right, so you can, this is kind of what some of you were asking about, you can determine how many solutions a system has without even turning to a graph. Okay, the key is to put the equations into blank blank form, slope intercept. Yeah. So if we put the equations into slope intercept form, we should be able to determine how many answers the system will have without doing any graphing whatsoever. So let's take a look at number 5 coming up here next. All right, with number 5, if you guys would, let's put both of those into slope intercept form. Again, you guys showed some pretty remarkably good skill in doing this in the last chapter. So let's take just a minute and put both of those into slope intercept form, and then we'll make our determination as to how many solutions this system has. So those are our slope intercept equations for the system. Let's talk about what it means and how we could use this information to arrive at an answer. Guys, the key is really simple. The key is look at the slopes first. Okay? So if you look at the slopes, I'll highlight them up here for you. If you look at those slopes, you ask yourself the first question is really simple. Are the slopes the same?
No.
They are not. They are definitely not the same. So we can immediately come to a conclusion right now. If the slopes are not the same, then how many solutions will we have?
1.
Won't the lines cross? Yeah, you'll have 1. So we would say, determine number of solutions. I'd say that there will be 1 solution. And if you were pushed for a reason, you would say 1 solution because slopes are different.
And the y-intercepts.
That actually makes no difference. And you're right, the y-intercepts are different, but just because the slopes are different, we know there's 1 solution.
Yeah, if the y-intercepts are the same, but the slopes are different, it's still okay.
It would cross at the y-intercept, wouldn't
Yeah,
it?
they have to both be the same.
Yeah, I thought you were asking where it crossed, and then I thought it was a positive 10, so I had 2, like 2. Positive.
Oh, yeah, I wasn't really asking for what the solution was. I was just more interested in how many are there. So this one only has 1 solution, and we could find it by graphing it, if we wanted to. Yeah, okay, awesome. Let's take a look at number 6. Number 6 really is kind of the same sort of question. Again, it says, without graphing, determine the number of solutions. So like before, the key to this is going to be put it in slope-intercept form first. So take just a minute and do that. Put it into slope-intercept form. I will do the same up here. Colby, do you agree with what Rocky said with those slope-intercept forms? Okay. So what should be the first thing that we compare to decide how many solutions there are?
The slopes.
Okay, so the slopes are what?
The same as -2x.
Negative, yeah, both of them are -2, right? Both of them are -2. So the slopes are the same. So if the slopes are the same, we got to go to one more step further, right? And what do we look at next?
The y-intercepts
Right, and so the y-intercepts?
are the same.
So if the slopes are the same and the y-intercepts are the same, what conclusion do we draw?
Infinite number of solutions.
Because it's the same line, isn't it? Yeah, so these two lines are right on top of each other. Colby, you are correct. We would say infinitely many solutions. Or you could say all real numbers work here. What if we had done what we just did with Colby there for a second, and we said, okay, the slopes are the same, but what if the y-intercepts were different? What, parallel lines, meaning
No solution.
no solution, right? The lines would never cross. So that's also a possibility. Okay, will you guys get out your graphing calculators? We're going to take a look at our final example here, number 7.
I don't know if mine is a graph.
It is. That's definitely a graphing calculator.
Okay.
Yeah, you do like the y equals.
So number 7, it says a graphing calculator can be a very useful tool. So if you have like the TI-84, will you guys hold your calculators up really quick?
I have
We'll
the
just-
same one Avery has.
Okay, so all of you guys, yeah, that's good. All TI-84 type stuff, yep, that's good. Colby, did you bring yours today? You got one? Yep, okay. And Evan, you have yours? Awesome. I think we're in pretty good shape here. Alec, no,
I
yes.
lost mine, I just need to find it.
Okay, good deal. But do you have an 84 kind of like these other folks? Okay, good deal. So you should be,
Mine's at my house.
you're good. Yeah, you said you had one like Avery. Is it pink too? Nice. Okay, so you'll be able to see on the screen here in just a second how we do this. But what we got to do before you go to your calculators, we got to do just a little bit of work with this system. We need to put this system, like we've been doing, into slope-intercept form, okay? Slope-intercept form. And so let's go with that here first. I'll go ahead and work that out while you guys are doing the same thing. I've got mine up there. You can feel free to check. Don't forget there's that negative on the y, right? So that'll change things a little bit there. We good? So in order for the calculator to be so nice for you, you've got to be in slope-intercept form. You guys ready to go with this? Okay, so let me show you how we use our calculators to make this work. See if I can just get this to show up. Right here. Okay. There we go. Okay, so here's what I want you guys to do. When you turn your calculator on, you have a, well, see, maybe, do you have just a screen like that maybe? Okay, so can you guys, oh, you can't see really. Just look for the red button. You guys see the y equals button? It's the far upper left button. It's turning red right now. If you push y equals, you should get that screen right there. We all there? So this is where you got to be really honest. Like if there's any amount of being lost on this, you got to say something. So we're all okay? All right. So what we're going to do is we're going to put the equation of our first line in there. Our first line was at negative 2x plus 12. Okay, so the negative is down here. So just look for the red button pushes. So negative 2 and then x. The x is up here right below the mode button. See the X just turned red? See that red button? That's the button I pushed in order to get the X to show up. Make sense? Okay, so negative 2x plus 12. So we're going to input that in there. And then I'm going to scroll down and we're going to put our other equation in the y2. So that was just 2x plus 2, wasn't it? So similar button pushes here. 2. Once again, the X is up here. The button that's red right now, that's what you push to get an X, and then plus 2. Yes, Jake?
Isn't there another way to do the X?
Don't do it. Just do that.
Just do that?
Yep, just do that. It's way better. It's faster. It's one button push. It's better. Okay, so right now, at this point, are we all right there? We all have that screen? All right, so to get a standard window, like you could push the graph button on the upper right, but to get a standard window, I always like to push, you push the button Zoom 6. So Zoom is right there in the top middle of those skinny buttons. So if you just push Zoom and then the number 6, it'll get you a standard window. So Zoom 6.
I have an error.
Dimension mismatch. If you have an error, come over here, please. Because your plot 1 is on. Turn your plot 1 off, hit graph, now we're good. If you have an error, walk over here, please.
Oh, okay, I got it.
You can, but depending on what your window can be moved all over the place. So Zoom 6 will always give you a standard window. We're going to talk about how to move your window around. We can like zoom way in, zoom way out, move the window over here, move the window over there. Zoom 6 will always return you to a standard window. Yes?
So if you zoomed in, will you be able to see like the points that they intersect at?
Well, we don't need to do that. You could, though. You could zoom in on that intersection point, definitely. But we don't need to do that. Got a few more button pushes for you, but before we do we all see that exact same screen? Maybe without the colors, but that exact same screen?
Yes.
No? Hurry up. If there's any issue, you need to come over here right away like Evan is. Okay. Hurry. Pick up the pace, my friend. Let's go. I can help you. All right, so we're going to push some more buttons here in a second. And we hit graph. Okay, syntax. So what that means is probably Down here below, you have some other crazy equation. Let's find it. Where is it? Nope. Okay, what did you, oh, I think I know what you did. For your, so for your negative, you pushed minus.
Oh, I
They got a
put
whole
minus.
other button for negative.
Oh.
So push the negative button, and it should give you what you want. Let me know if that works right away, okay? Okay, good deal. So do you all see the intersection point right there? You can see it. You could estimate it. It's right in there somewhere. It's in the first quadrant. Here's how we actually find it. Your calculator will do all of the work for you from here on out. Here's what you do. You see the blue button, second?
Yeah.
Push that one. Second. And then right above the trace button, you see how it says calc? Trace is right below the screen. It's one of those skinny buttons. I'll push it right now. You see the red button?
Do we press it?
Yep, go ahead and press it. So second, calc. Now I'll let you guess. Which one of these do you think we want? Yes, Rocky. Number 5 is intersect, right? We're looking for where the lines actually intersect. So go ahead and select option 5. You can just push the 5 button. So second, calc 5. And now it's going to ask you which curve is the first curve. Now let's just be honest. How many, everything is a curve really, even a line is called a curve. But how many graphs did we graph? 2. So does it really matter which one is the first one? No. It doesn't. So just go ahead and hit enter. And then it'll say, oh, is the other one the second curve? Well, since we only graphed 2 of them, the answer is yeah. So basically what you're going to do for the first 2 prompts, you're going to go enter, enter. It's really simple. So hit enter again, and then it wants a guess. Now, how many places could 2 lines even cross?
1.
Yeah, it's either 1, none, or infinitely many, right? It can't be 2 or 3. And so there's only 1 intersection point. If you want to scroll over there, see how you can move the little cursor thing over there? You can if you want, but you really don't even have to move it over there. Get it sort of close if you want, and then hit enter one more. Hey guys, hit enter one more time, and it'll actually spit out the answer. 2.5 comma 7 is where those 2 lines intersect. So your calculator is potentially, do you see how it's potentially a very powerful tool in figuring these things out? It'll do all that work for you. It'll graph it, it'll find the intersection point in one nice neat package, hopefully. Okay, we good? Okay, very nice. Nice work today.